Hello everyone. I'm sure you love these type of plants. How do you feel when you see these plants? These beautiful tropical plants. Actually, because they are very beautiful and they are not in other countries, those temperate countries, we can sell these plants and export these plants to other countries. So that is why we developed a research project having this in mind to produce large number of prototype plants using micropropagation. So our research project is commercialization of low-cost micropropagation for export and production of improved ornamental plants through genetic modifications. This is our RIC Grant 1 awarded from a head World Bank project. I am the principal investigator. We have 9 members in our project, 2 from SLIIT, 1 from Sri Jayawardhanapura University, another one from Haley's Agrobiotech Company Private Limited, and another one from University of Peradeniya, and another one from University of Adelaide, Australia. And we have 3 research assistants in our project. Our research project is developed with 3 objectives. The first objective is to commercialize the low-cost technique and export in vitro rooted plants through the In Vitro Growers Association. This low-cost technique will reduce initial cost in 90%. So those who have interest, they do not have to spend a lot of money to establish a tissue culture lab. So to disseminate this knowledge, we established an association, which is called Association of Sri Lanka Growers of Plant Tissue Culture. We have about 25 members now, and they also have research problems. So through MOUs with them, we carry out their research requirements and we disseminate this knowledge to them to grow more plants. Also, we have workshops for general public, and some of them who attended these workshops have started tissue culture labs now. Then to facilitate all that, I have written a monograph. Through that, they get very good knowledge in tissue culture to start tissue culture labs and carry out until export. And also we have mandate to give these growers plants to multiply. We initiate plants and give these plants for them to multiply. This is the Astroptic website, which our growers can link with, and they can publish their products or their plants, and they can connect with the other countries, and people who market these plants can contact them and they can sell their plants without a problem. So this is very beneficial for our growers. This is a monograph I was talking about. This monograph contains how to start tissue culture labs with low-cost applications, and then they can carry out until they export the plants. The knowledge required is given in this monograph. Also, as I said earlier, we have the mandate to give initiated plants for our members. So we have initiated these plants: Euonymus, Dracena, Dianella, Syngonium, Caladium varieties, Cordyline, Plectranthus, Aglonema, Syndapsus, Osbeckia, Epiphyllum, Oxypellum, which is Kadupul, and most of these plants are now established and ready to multiply, and some of them have been given to our growers, and some will still wait until substantial multiplication is achieved. Also, we have in mind to give these plants, so there are new varieties of caladium which is now being established, and very soon we can deliver these plants also. Then we have our second objective to eliminate microbes in plants, on plants. Both microbes are endophytes and they live inside plants also. And as you know, a lot of dust particles come onto plants, and those dust particles carry microorganisms. So we have to eliminate all that when we establish plant parts in tissue culture, because our medium contains sugar. So it's a very good medium for microbes to grow. So we developed this titanium dioxide nanohybrid, which we got 90% contaminated free, microorganisms free cultures. And this has been patented internationally. Actually, the process is still going on, and that titanium dioxide nanohybrid will take away 90% of microorganisms which are adhered onto the plant parts. And that is not enough, because, as I said, there are microbes which are growing inside the plants. So we develop another nanomaterial, nanosulfur, to get rid of or to destroy those which are living inside. So combining both, we hope to get more than 95% success rate. Even though we have 90% success rate at the beginning, once they are in culture, these endophytes will come out and grow in culture if we do not eliminate endophytes using some kind of material. So that's why we develop nanosulfur, which can absorb into the plant and kill microorganisms. Then our objective number 3 is genetic modification, where we will apply radiation like gamma radiation and chemicals, ethyl methane sulfonate, which are chemical mutagens. So these can change the genetic makeup of the plant, and they can produce new varieties. So we have applied these to these plants particularly, and there are some more plants that we have applied, and after the mutagenic application, these plants grew, and still we don't know whether they have change or not. But we have to do is we have to check it with DNA markers. We will use molecular markers to check whether they have changed their genetic profile, DNA profile. And then that is also not enough. We have to acclimatize them and go outside world. We have to wait until they flower. Some of these plants will flower and they will produce seeds. Those seeds should be germinated. We have to wait until they produce plant to see whether they have the change morphology. So it's a long procedure. Other than that, we are hoping to apply UV radiation also. UV also, ultraviolet, can change DNA sequence, or we can get new plants out of it. So we applied this for cordyline, anthurium, cyanotic, Osbeckia, Grammatophyllum. And whatever we establish in our tissue culture lab will be exposed to these, and especially we will be applying UV radiation, especially UVB will change genetic makeup of the plant. So we are hopeful we will get new plants which will be saleable. If the plants are beautiful, only we can sell, like I said at the beginning. So hope for the best. We'll wait and see. Thank you very much. And I get this opportunity to thank Ahead Project for giving this grant for us to carry out this valuable research. Thank you very much.